When we look at the squares on a checkerboard or a chessboard, you right away see all these little squares going down, going across. Well, there's 8 down, 8 across, and 8 times 8 is 64. But there's a lot more squares than that. If you look here, you have a 2 by 2 square. You even have a 3 by 3 square, all the way to 4 by 4, and it keeps working its way all the way up to 8 by 8. And how many of those go down and how many of those go across? Well, that's what we're going to find out. If we draw a few of the squares, you can see that right here is a 2 by 2. Here is a 3 by 3. Here is a 4 by 4. And the pattern continues on and on until we have an 8 by 8, which is the entire chessboard. Now when we look at each little square, that's a 1 by 1 square, we can see that there's 8 1 by 1 squares going down and 8 1 by 1 squares going across. To find all of them, we would take the 8 times 8, which equals 64 1 by 1 squares. Now when we look at each square as a 2 by 2, right here, we can see that every time we shift down to make a new 2 by 2, that we take care of covering the space as we move down the chessboard. So there's 7 2 by 2 squares possible going down. There's also 7 possible 2 by 2s going across. To get all of these ones in this area, all we need to do is multiply the 7 times the 7. 7 times 7 equals 49 2 by 2 squares. Now when we look at the next size square, it's a 3 by 3 square, which would give us 3 by 3. There are 6 3 by 3 squares going down the chessboard and 6 3 by 3 squares going across. To find all of these ones again, we would multiply the 6 by the 6, which equals 36 3 by 3 squares. The next size is a 4 by 4 square. So you have 4 by 4. Okay. As you move down, you have 5 4 by 4 squares. And as you move across, you have 5 4 by 4 squares. To find all the ones in the middle, you multiply again. 5 times 5 equals 25 4 by 4 squares. The next size squares are 5 by 5s. You have a 5 by 5. And as you move down, there is 4 5 by 5 squares going down. And there are 4 5 by 5 squares going across. To find all the ones in the middle, you have 4 times 4 equals 16 5 by 5 squares. The next size square is a 6 by 6. You can see that there's 6 by 6. There's 3 6 by 6 squares moving down and 3 6 by 6 squares moving across. 3 by 3 equals 9 6 by 6 squares, which gives you all the 6 by squares possible. The next size square is a 7 by 7 square. A 7 by 7. So you can see that there's 2 7 by 7 squares going down and 2 7 by 7 squares going across, which gives you 2 times 2 equals 4 7 by 7 squares possible. The last size square possible is an 8 by 8, which is the entire chessboard. So there's only one giant square here of an 8 by 8 square. Now that we've written down all of our square totals for each size square, here's your size of each square. And here's the totals of that many squares on the chessboard. We can total out the amount. When we total out the amount, you can also notice that each one of these answers is a perfect square. So when we total these out, we will get 204 squares total on the chessboard. That's a unique answer because there isn't a square number that goes into that, even though we do have all squared numbers here. So what you can see here is this here is an 8 squared, 7 squared, 6 squared, 5 squared, 4 squared, 3 squared, 2 squared, and 1 squared. So really any size board with any amount of numbers you could find, because all you would need to do is take the size of the board, which if it was 8 by 8 is the highest number, and work your way down all the way to 1 squared. If you had, say, a 25 by 25 size chessboard, it would start with 25 and work its way down 24, 23, 22, all the way down to 1 squared, and then there would be the total number of squares. Now I want to show you a video on YouTube of a teacher teaching algebra to her kids in Europe, using the same technique to show patterns and to show how easy it is to find something once you see a rule.
Chessboard. Who can remind me and the rest of the class what we did?
We had to find out how many squares there were in the chessboard, including squares made from 4, 9 and all of the different ones.
Ultimately, I wanted the children to discover if a chessboard was made that was 25 squares in length, how many squares they would find. We're going to start by looking at how many squares are in a chessboard with 1 square, 4 squares, 9 squares, and then go on to 16 squares. But we're not, you'll be pleased to hear, going to do that all the way up to 25. What do you think we're going to work out along the way?
Well, you might be able to find a pattern once you're starting it. So after about 8 by 8, you might start to find a pattern, and then that could help you.
So what you see is that not only did our squares show it, and will help students learn how to find an algebraic pattern to numbers, but there are kids all over the world learning how to do this. Thank you, and that is my video for our digital story.